Hi, this is János and we are looking again at Real Cat Kintaro, and this is Real World Audio. He is ready to go to sleep. I've been making all of these videos on how to start out having stuff for DIYers, and now let's continue it with a very practical thing, and these are dummy loads and bleeder resistors. This is a vital tool for you when you work on amplifiers, and this is something that you make for yourself. And you will need alligator clips. So you see, these are the alligator clips right there, and basically you need alligator clip, a piece of insulated wire, and a resistor. So you get your alligator clip, solder it to a piece of wire, and the right wire, solder it to the resistor, and the same thing for the other end, other lead of the resistor. And that's when you are, now you see this broke off, and that's what happens to your tools if you use them for a while. I've been using this for like 20 years and it just gave it up. Easy peasy, just resolder it and it will be ready to go. So when that happens to you, it's not the end of the world, just resolder and the show goes on. So what do we see here? So let's look what's in the center. This is, as you see, it says 7.8 ohms. So this is a dummy load that's made with two 15.6 ohm resistors in series, and each of them are 25 watts rated. So this is a 7.8 ohm dummy load, so an approximately 8 ohm dummy rated at 50 watts together. So what I'm using this is when I'm testing an amplifier, then I attach this instead of a loudspeaker, and you know, if it has like oscillations or some problems, it won't bust your loudspeaker, but it has this nice load instead. So you need one of these dummy loads to test an amplifier. And you would say that I need a non-inductive load. You need a non-inductive resistor if you want to make like precise measurements for publications. Yep. But I would say even if you want to measure it, so if you have a like let's say a nice oscilloscope and you want to measure like the sine waves outputs of your amplifier, then if you have a non-inductive load, then you will see those really pretty outputs. But actually an inductive load, I prefer to use that because it's going to give you a more realistic presentation of what's going to happen with your loudspeaker, because loudspeakers are inductive loads, and even if you don't have a crossover, it behaves a little bit similar to how this wire wound resistor works, because it's just wire wound in a circular fashion, and the same thing happens in this resistor too. It's wire wound because it's a piece of wire wound in circles, but here it's encased in a ceramic casing, in sand basically. So anyway, you don't need to buy a non-inductive resistor because non-inductive resistors are quite a bit more expensive than inductive cousins, and inductive is fine. Just hook them to a piece of wire, and then you can hook this up to the loudspeaker terminals when you are testing your amplifier. Perfect. Now, what do you need those three? Those are bleeder resistors, and you see they have clips on end, and that's because you want to clip these guys into your amplifier. So here we go. What do you do? I got the clip stuck in my microphone wire here, so I got it out. Perfect. So what you can do is bleeding. So you get 1 point. It's kind of hard to do this with one hand only. So here this is the ground, here, ground wire. So you hook up, actually this is my hot. I have my glasses on now. So here we will have the ground. I have not soldered it in, but you will see a wire here, that's the ground. So connect that part to the ground. And then you have the other, it's kind of tangled up together. So let me just untangle it, not easy a task. When you can use both hands, not holding a camera, it's a no-brainer, but now it's kind of difficult. And what you do, you see there's insulation. You see there? Now you see it. So there's insulation around the clip, and then you can just stick it to the positive, and then it will bleed. So what will happen is that it will drain the capacitor. And that's what a bleeder is. It drains the capacitor out of its voltage, and then it will be safe to work on. Because if you have a tube amplifier and you want to open it up to work on it, if you turn it on, plug it out from the wall, and you reach inside, it zaps you, and you will likely get severely damaged or maybe die. Or, I mean, not damaged, injured, maybe damaged as well. But first you need to bleed it, so you need to discharge the capacitor, and you cannot just discharge that you get like a piece of metal and just short it. If you do that, it will you will see the formation of plasma when it's like a 500 volt supply, and it will be a really loud bang, and you will smell how molten copper smells, and there's a chance that you will also damage the capacitor, and it can also give you a nasty lethal shock through holding that metal piece. So anyway, that's a really bad idea to do. Instead, use a resistor. So you attach a resistor between the positive and the negative, and it will slowly drain the voltage. So what I have here, this is a 10 kilo ohm resistor that's rated at 20 watts. And when you attach it here, actually this is getting quite warm and quite hot if you are draining 400 volts with it. And you need something like between like 10 kilo ohm to 30 kilo ohm, and rated at 20 watts or higher to drain the B plus for around up to 450 volts or so. And if you want to drain like, let's say, a 700 watts, then I would say then what you need is even higher resistance. Then you would need at least 100 kilo ohm or more, and rated at least 25 watts or more. And the higher your voltage that you need to drain, the higher the kilo ohms you need to drain. And if you have just a low voltage supply you need to drain, let's say you have a DC filament, which I do not have here, but these are the filament transformers. So if you would have the DC supply section there, then for that you need to drain that, and then the 20 kilo ohm or 100 kilo ohm is just too much. It would drain it for sure, but it would take you a very long time to drain. So then you would just need something like 100 ohm or less to drain it nice and slow. And when the draining is happening, test it with a multimeter, what's the remaining voltage, and when it gets close to zero, then it's safe to work on. And what is very important for these very high voltages, like 400 volts and higher, or even if it's just 200 watts, or even if it's just 50 volt, but a solid state amp with massive, huge capacitor banks, keep the bleeder on while you are working, because even though you have drained it to 0 volts, many of the capacitors have so-called memory, and they will recharge. So if you, let's say these guys here, even though you drain them, but then like within a period of time they might recharge up to 100 volt by themselves and give you a nasty zap. Especially oil capacitors, like the big oil capacitors, they have a tendency to have an extremely good memory. so they will recharge up to quite high voltages and give you the nastiest shock you never expected. That's why keep the bleeder on at all times when you are working with an amplifier. And then make sure that when you turn on the amp, remove the bleeder first, because if you leave it on, then it will continuously try to bleed the voltage, and most likely the rating will be insufficient for your resistor, so it will heat up. And I have seen a bleeder that was left on an operating unit just turn bright red, and then I just dived for the power switch to turn the power off before it blew up or it just melted and created a fire. So yep, that can happen. Learn from it. Never leave the bleeder on when you are ready to test the unit. So before you test, remove the bleeder. Before you test, attach the bleeder. And before you do anything, measure the voltages with a multimeter. So thank you guys, this was the bleeder resistor, and have an awesome day. Please like if you like, subscribe if you have not yet, and be safe, and just make sure that you understand that electronics have very high voltages, dangerous voltages. Anything that plugs into the wall is not child's play. You must be certified and trained to work with this stuff. And I explained that more in detail in the previous video. And that's it. Bye bye.